the calculation that we are going to see is for liquid lens. So you can see the aim is to find the refractive index of a given liquid. In this case we are going to use water by using a convex lens and a plane mirror. Okay, so this is the aim. The formula here is mu, that is the refractive index, is equal to 2 minus Fa by Fw. Okay, so in order to know how you got the formula, you can go and learn the theory of liquid lens. You will be getting it clear there. Okay, so mu is equal to 2 minus Fa by Fw. What is Fa and Fw? That is what we are going to calculate. So here you must write no unit. Okay, and then you will write the procedure and the diagram. You can also draw two diagrams, one with air and one with water. So while with drawing with water, you can mention the water or the liquid here below the convex lens. Okay, so in the first table what we are going to do is we are going to take the readings without the liquid. Okay, so that is in air, that is Fa. You are going to find the focal length Fa. Okay, so the first reading is around 10.1. okay, 1 minute. Yes, 10.1. This will be around 10.9. This is just a sample. 10.0, 10.8. Okay, so then you will be taking the average of these two. Okay, so what is 10.1 plus 10.9 divided by 2? Now while taking the average 10.1, when you type in the calculator 10.1 plus 10.9 divide by 2, if you type like this, these two values will be divided first and then that value will be added with 10.1, which will be wrong. So what you have to do is you have to use a bracket. Okay, or what you will do is first you will add these values and get the answer. That answer you will divide by 2. Okay, so any one method you can follow. Don't write the formula in the single stretch, otherwise you will get a wrong answer. Okay, so the average will be 10.5. Here the average will be around 10.4, and then when you take the average of these two, okay, 10.5 plus 10.4 divided by 2, you are getting the average to be 10.5 centimeter. So what is our focal length of the convex lens in air? Focal length of convex lens in air is equal to 10.5 centimeter. Now we have to calculate same way the readings for Fw. Okay, so when you do for Fw, you will be getting around 15.3, 16.1, 15.0, 15.8. so that will be equal to, here you take the average of these two, so you will be getting 15.7 and 15.4. so when you do the average of 15.7 plus 15.4 divided by 2, you get 15.55. that will be rounded off as 15.6 centimeter. Okay, so what is the Fa value that we got? 10.5. what is the Fw value we got? 15.6. okay, 15.6. so the formula is 2 minus Fa divided by Fw. Okay, so once again, when you are having multiple operators like negative, subtraction, division, etc., you must use the bracket. Okay, so when you type in the calculator, how will you type? You will type 2 minus, open the bracket, 10.5 divided by 15.6. okay, you will type like this. If you type without the bracket, then 2 minus 10.5 alone will be done separate and this will be done separate. Okay, so that will be wrong, right? So you have to use the bracket while dividing or subtracting like this in a complex way. So 2 minus, okay, open the bracket, 10.5 divided by 15.6. so that is going to give me 1.326, which I will round it off to 2 decimal places, so that will be 1.33. okay, so the final refractive index of the water or the given liquid, here in this case it is water, is 1.33, and here also you will write no unit. Okay, so even if there is no unit, you have to mention no unit, and make sure you write centimeter everywhere. Even inside this you have to write centimeter everywhere. Okay, here centimeter, here also you have to write centimeter, and then the formula also you can write here no unit. Okay, centimeter. Okay, make sure to draw the ray diagrams, the arrow marks in the ray diagram. Okay, so do not submit the paper without drawing the arrow mark. Is it clear? So I hope the liquid lens calculation is clear for you.